Hello everyone, I am Dr. VRAO. I hope you are all fine and doing well. Today I am here with a new concept, that is titration of acids and bases and pH of a mixture of acids and bases. Titration of acids and bases and pH of mixture of acids and bases. Okay. So, titration of acids and bases and pH of mixture of acids and bases. Before we are going to know about this concept, at the outset, let us know what is meant by titration. What is meant by titration? So, titration is the volumetric method by which we can estimate the concentration of one if the other is known. I repeat, titration is a volumetric method by which we can estimate the concentration of one if the other is known. Therefore, titration involves two chemical substances or two chemical solutions. I repeat, by the definition of titration, titration involves two chemical substances or two solutions. Right? There are several types of titrations are there. One is acid-base titrations, redox titrations, precipitation titrations, complexometric titrations. There are several types of titrations are there: acid base titrations, redox titrations, precipitation titrations and complexometric titrations. When we concerns with titrations, we need to know the terminology of titration. Those are, the terminology includes titrant, analyte, equivalence point or equivalence point, end point and indicator So, to understand the titration of acids and bases and pH of mixture of acids and bases, you have to know the concept of what is meant by titration and what are the types of titrations and what is the terminology of the titration. So, the terminology of titration includes titrant, analyte, equivalence point, end point, indicator. Okay. So, in these classes and that is in this video and in the upcoming video, we are going to learn about acid base titrations, because our objective is pH of mixture of acids. We can calculate the pH of acids and bases, right. In fact, pH, we can calculate the pH of acids and pOH of the bases, right. So, we need to know the terminology of titrations: titrant, analyte, equivalence point and indicator. right? Titrant. By the definition of titration, we came to know that titration involves two solutions. And that two solutions, one is titrant and the other one is analyte. So what is meant by titrant? Titrant is the solution of a known concentration. Titrant is the solution of known concentration. Okay, so titrant is the solution of known concentration. Known concentration. Analyte. Analyte is the solution that is being analyzed. Analyte is the solution that is being analyzed. That is whose concentration is unknown. Unknown concentration. So by the definition, what is the definition of titration? Titration is a volumetric method by which we can estimate the concentration of one if the other is known. If that other is known. So known solution, the solution whose concentration is known is called as a titrant, right? And the solution that is to be analyzed is called analyte, right? And the other one is equivalence point or equivalence point. Equivalence point is the point where the volume of titrant and the volume of analyte are equal, where complete neutralization takes place, right? So equivalence point is the point where the volume of titrant is equal to volume of analyte. Volume of analyte. So the volume of titrant and the volume of analyte are equal. That is where the complete neutralization takes place. We use the neutralization term for acid-base reactions or acid-base titrations, and of course it can use for other titrations also, but we use the neutralization term for acid-base titrations, right? So equivalence point is the point where the volume of titrant is equal to volume of analyte, right? That is where complete neutralization takes place. That is theoretically titration is completed. And one more thing is that equivalence point is the point where the titration is completed theoretically, right? And the end point is the point, it is just above the equivalence point. End point is the point, it is just above the equivalence point, that is 0.1 ml, it is less than or equal to 0.1 ml above the equivalence point. Okay, end point is the point, it is just above the equivalence point. How much above the equivalence point? So it is less than or equal to 0.1 ml. Okay, it is 0.1 ml, less than or equal to 0.1 ml is more of the volume of titrant at end point. At end point, the volume of the titrant is less than or equal to 0.1 ml of titrant, right? Okay, so titrant, the titrant volume is less than or equal to 0.1 ml, right? That is end point where actually equivalence point is the end of titration theoretically, but in practice, practically titration is not over at equivalence point, because we have to know the completion of titration. Okay, we have to know the completion of titration, and we can know the completion of titration at the end point only, at the end point only. So, what is the end point? End point is just above the equivalence point. It is greater than or equal to 0.1 ml of the, sorry, it is less than or equal to 0.1 ml more in volume at the equivalence point. Okay, and a end point is practical end of titration. That is, it denotes the actually end point. By the end point, we came to know the end of the titration, because end point where at end point color change takes place. At end point, color change takes place. Okay, so you keep one word in your mind, that equivalence point, it is the point where the titration is completed theoretically. End point, it is just above the equivalence point, and it is practical end of titration. Okay, so at end point color change takes place. By that color change, we came to know the titration is completed, right? And when, and one more thing is, when we are adding, usually we take known concentrated solution in burette, that is titrant, and unknown concentrated solution is taken in conical flask, that is analyte, right? So, known concentrated solution is taken in burette, that is titrant. Unknown concentrated solution is taken in conical flask, that is analyte. Titrant, analyte, right? So, usually we take known concentrated solution in burette, that is titrant. So, titrant is a solution whose concentration is known, and unknown concentrated solution, that is that solution that is to be analyzed, is taken in conical flask. But sometimes we take vice versa, right? But the thing is, when we are adding titrant to analyte, the resulting solution pH undergoes change. I repeat, when we are titrating, or when we are adding titrant to analyte, the resulting solution pH undergoes change. Okay, so in the next video we shall do some problems based on the pH. We shall do some problems on pH of the resulting solution when the titration is going on, right? And let us have a look on indicator. Let us have a look on indicator. Let us have a look on indicator. What is meant by indicator? Indicator is a litmus solution by which we can or it indicates the end point of the acid base titration by undergoing color change. I repeat, indicator is a litmus solution. Indicator is a litmus solution which indicates the end point of acid base titration by undergoing color change, right. So, indicator undergoes color change, and that color change will that color change makes to whether that color change tells whether the titration is over or not. Okay, if the color change takes place, that means titration is completed, right. So, indicator that undergoes color change, and that will that gives the information that titration is over, right. So, there are there are different indicators are there. Usually indicators are weak organic acids or weak organic bases. Weak organic acids, weak organic acids. Indicators are weak organic acids and weak organic bases. Examples of indicators are methyl orange, methyl orange, methyl orange, phenolphthalein, methyl red, phenol red, etc., etc. Okay, so there are different indicators are there, several indicators are there. Okay, and you should keep one thing in your mind: indicators are weak organic acids or weak organic bases, right. Let us know about the indicators, that is okay. So, indicators are weak organic acids or weak organic bases, right, and that indicators undergo color change during the titration, and they give the information that titration is completed, right. So, methyl orange, methyl phenolphthalein are the we are using these two indicators are very we often use these two indicators in our usual titrations. Methyl orange is denoted by MEOH, that is it is a weak organic base, it is a weak organic base and there exists a equilibrium between Me plus and OH minus ions. So, this is the molecular form, of methyl orange, and this is the ionic form of methyl orange. Okay. So, there exists a equilibrium between molecular form and ionic form, and one more thing is every indicator has its own pH range. Every indicator has its own pH range. pH range of methyl orange is 3.2 to 4.4, and the phenolphthalein pH range is 8 to 10. Okay, and methyl red is 4.4 to 6.2. Okay, so every indicator has its own pH range. Okay, so methyl orange establishes a equilibrium, and there exists a equilibrium between molecular form of methyl orange and ionic form of methyl orange, and the ionic form is red in color in acidic medium, red in color in acidic medium, and yellow in color in basic medium, yellow in color in basic medium. Okay, there exists a equilibrium between ionic form and molecular form. In the strong acidic medium, that is we are providing H plus ions, those H plus ions combines with OH minus ions, and the number of OH minus ions decreases, and the equilibrium shifted to right side, and the indicator will have the red color in the acidic medium, right. So, the pH range of this indicator is 3.2 to 4.4. Okay. So, it is the pH range of acids. So, usually we use this indicator for strong acid weak base titrations. Okay. And we can use this indicator for strong acid versus strong base titrations also, right. And another indicator is phenolphthalein indicator. Phenolphthalein is denoted by HPH, and there exists equilibrium between H plus and pH minus ions. Okay, and this is the molecular form and this is the ionic form, and the ionic form has pink color in basic medium, pink in color in basic medium, and colorless in acidic medium, colorless in acidic medium. Okay, and the action of indicators was explained by two theories. What are the two theories? Ostwald theory, and the another one is quinonoid theory. Okay, Ostwald theory explains the action of indicator based on the molecular and ionic forms of indicators, and that theory, according to that theory, ionic form is deeper in color, and another theory is quinonoid theory. Quinonoid theory explains the action of indicator based on the benzenoid and quinonoid forms, Okay, so what is the benzenoid form is this is the benzenoid form, and there exists an equilibrium between benzenoid form and quinonoid form. Okay, that is the quinonoid form. So, it is a benzenoid form, and this is the quinonoid form. And quinonoid form is deeper in color. Okay, so these are the two theories that explain the action of indicators, and the action of indicator action is explained by Ostwald theory by considering the molecular and ionic forms, and quinonoid theory explained the indicator action based on the benzenoid and quinonoid forms. Okay, so what we should remember is that indicator is a litmus solution, okay, which indicates the end point, of acid base titration or whatever the titration is by undergoing color change. So, actually color, the substance which is being undergoes color change is indicator. So, indicator is very crucial in finding the end point of the titrations, right. Okay. And one more thing that should be keep in your mind is that there is a difference between equivalence point and end point. Equivalence point is theoretical completion of titration, but the end point is practical completion of titration. That is, end point is greater than, end point is more in volume than equivalence point, that is less than or equal to 0.1 ml, right. So, I hope you all understand this the terminology of titration, because we are doing problems in the next video, that is titration of acids and bases, that is pH of a mixture of acids and bases. So, to understand that concept we should know this terminology. Okay. And one more thing is that there is a selection of indicators, that is for every titration. For strong acid, strong base titration, you can use the any of the indicator, but for strong acid, weak base titrations, that is in that combination acid is strong. So, acid is strong, we can use the methyl orange indicator for strong acid weak base titrations. And strong base weak acid titrations, we can use the phenolphthalein indicator, because strong base there. So, base phenolphthalein indicator range is 8 to 10, we can use the phenolphthalein indicator for strong base weak acid titrations. And there is no appropriate indicator for weak acid and weak base titrations, and if condition demands, we can use methyl red as an indicator for weak acid and weak base titrations. Okay. I hope you all understand this concept. In the next video, we shall do some problems on pH of the resulting solution when the titration is going on. Thank you. Thank you for watching.